Hello, everyone. I'm Hua from Uber logging and search team. Welcome to Tech Day. I'm about to talk to you about what we do with logging and search at Uber. A little bit about me before I get started. So I went to Peking University with my bachelor degree in computer science and then got my master from UU. And my first job was with Microsoft. About a little bit less than 3 years ago, I decided to join Uber and start my journey here. It's been very exciting, and we're happy to share with you. So today, I'm going to talk to you a little bit about the overview of what we have done, and we will dig into logging and search separately. For each area, we will talk about the use cases, what the challenges are, and how we solve the challenges, and the roadmap into future. And at the end, we will have 5 minutes Q&A. So at Uber, we use Elastic for logging and search products. I'm just wondering how many people here heard of Elastic? Oh, cool. A lot of people know about Elastic here. So just a quick overview for people who are not familiar with Elastic product stack. Elastic search was first released in 2010, and it has been rising to be one of the most popular search engine and logging solutions. At the bottom, you can the log search and the beats. They are the log shippers, and Elasticsearch itself is the search and indexing engine. And Kibana is a UI component for users to visualize and query and do aggregation on top of the data. So those are the key components we use here at Uber. And we use all of those are open source. First, let's dive into logging. What is logging? On the right side, you can see this is a snapshot of what a system log. This is traditionally how you view what has happened in the system. And for today's day and age, when we, as you heard earlier this morning, that we have over 3,000 microservices, we have many distributed systems, serverless architecture. The logging we refer to is centralized logging service. That means the services are sending logging to us, and we provide a search experience on top to visualize and analyze your logs. So the top one scenario for logging is debugging. It's impossible to debug with the centralized logging system now. And with then you can use the data that's already injected to the system with lots of useful data in there. You can build data analytics for health insight into your system. So for example, like how many requests has failed, what's the top 10 error message you have in your system, and what's the P99 of the latency. So as you heard, we are using Elastic as the backbone for overlogging and search products. You may think it's just one of those elk use cases out there. So what's special about logging here at Uber? Since so many of you guys are familiar with Elastic here, you can see Overscale is one of the largest in the industry. We have over 1,000 Kafka topics onboarded to the system. The total data is 2.5 petabytes data stored on disk. That's only for about 7 days log in general. And so its ingestion speed is at 5 GB bytes per second. And that is hosted across 600 more than 600 hosts and growing. The project itself started in 2015 with one person. And ever since then, up until now, almost the entire company is using this system. And we are still a very small team. And so how did we do this? How did we manage this at such a large scale with such rapid growth? What are the main challenges? So to us, the main challenges are in two areas. The areas are very simple, actually, at a high level. So infrastructure and data. Infrastructure is mainly at the scalability. For Elastic, you can just take out their stack. You can have 2-3 nodes very fast and get that going very easily. So that's the benefit of using Elastic. But in order to scale to Uber's scale, there are lots of work that needs to be done in terms of managing the cluster operations on the operation side, make it have a robust production performance, and scale it in terms of multi-cluster, and how do we keep adding capacity? So, and on the data side, the data side is the data throughput management. The data size, the data is huge, as you can see. Only for 7 days is 2.5 petabytes. And also data format, because for logging, in order to make a good experience for engineers to be able to take advantage of the logging system, logging is free format. And so how do we make it easy in the end? Because we eventually need to be able to do aggregation and search on top of all the logs. How do we do that? So there's something we call structured logging. So I will deep dive into all the details with the component stack, introduction into the component stack, and we will also talk about the pipelines. So this is the main component stack. As we actually mentioned, all the green components are from Elastic, Elasticsearch, Logstash, and Beats. And the yellow boxes are are building on the similar pipeline. Those are actually what you heard in the morning from the streaming talk. As you can see, we have a Kafka in the middle. And Kafka is added for buffering and scalability. And on the side, we have the management components. So the management here, the operation is what I mentioned about cluster operation. So at more than 600 hosts and thousands of Elastic nodes, we have to build automation. And then lifecycle and SLA is more data side of management. So how do we manage the lifecycle of the data? Basically, we have a set of data retention policy. And the latency management is the main concern of the SLA, because we provide a near real-time ingestion. So it's critical for live production outage debugging. So all of that runs on our internal runtime integration on prime data centers. So we have our internal Peloton, UMetal, those are our internal components for resource allocation. And your services also runs on the same runtime. And we have logging APIs for each language that outputs logs to the system. And on this side, we have applications that can build on top of the logging data. Those are the dashboards I mentioned to you about the service health that you can use for reporting and alerting. And there's more service health applications you can build on top of this. So this gives you a main components that we have at Uber today that's around the logging. let's go talk into how data flows through the pipeline. It starts with your service. Your service logs through our logging client. So we have our own logging API. This is about data format control. Our API is semantic aware, so it builds data type information into the logs. And so at the end, when it reaches Elasticsearch, we can have some data type awareness. So that helps to solve the problem with free format logging. Filebeat is deployed on every host in Uber, and it ingests the local logs and sends it to Kafka. We implemented output plugin for Filebeat to output to Kafka REST proxy. So Kafka is added for buffering queuing of the messages. Kafka can scale by dividing a topic into partitions. So on this side of Logstash, we spend lots of time scaling Logstash into separate pipelines. A pipeline can contain multiple topics, and each topic maps to multiple Kafka partition. So for each partition, we can launch a container. That's how we scale this whole system. So this, so we are building the orchestration on top of Logstash pipelines. We are adding centralized config. We are hoping to have this system auto scale because this is essential for ingestion the over thousands of Kafka topics. So Elasticsearch, this is one of the key components. We spend lots of time working on scalability and the manageability of this component. So what we have is we have a proxy actually in front of the Elasticsearch. And the proxy can manage, we can build auditing information in the security. And Elasticsearch itself, because we actually find out with scalability, Elasticsearch cannot really scale horizontally to the overscale. So what we end up doing is we will split over Elasticsearch instance into multiple clusters. And we have the proxy sitting in front. The proxy knows how to route to a particular cluster. So that's how we implement multi-clusters. And we also have multi-tenancy hosts because there are certain ratio of CPU and memory. We find out which is best for elastic instances. So we can take advantage of hosting multiple elastic instances on one host. And in the end, this is Kibana. Kibana, we basically, this is one of the easiest to scale because it doesn't require lots of instances to host the Kibana. What we need to scale is just be able to isolate Kibana per use cases, per clusters, or a group of clusters. We need to support multiple versioning. So that's pretty much about Kibana. So from Kibana, that's where user actually be able to take advantage of the query aggregation and the UI to query to visualize their data. And all of those is happening near real time. So what's our roadmap? As I mentioned, we have a huge fleet of hardware, thousands of elastic nodes. So one area we have been working on and we need to continuously invest is automation. So we just keep doing automation and management tools. And one thing we are still working on is autoscale. Autoscale I mentioned a little bit in the Logstash pipeline. We also want to hopefully build autoscale into Elastic cluster layer. And self-onboarding is to improve our engineers' experience with the service that we want. The topics, we want to make it smooth for them to onboard the topics. And efficiency control. So anything with scalability I want to mention is you want to be able to scale, and the other side is be able to control. So you want to control your volume and your data size. So we're building rate limit, for example, cost accounting in this area. With that, we will go to search. So we started the search because we had our learning through logging. And because I mentioned with this large amount of logs, we need to be able to search on top of it. So, and we learned through building Elasticsearch, using that as a logging backend. We started providing Elasticsearch-as-a-Service. That is a search service, but using Elasticsearch as a backend. So Elasticsearch-as-a-Service at Uber, we started in late 2015, and we tailored the deployment to Uber by containerized using Docker. Evelyn will have a talk about Docker at 3:20. So nowadays, we have grown into more than 40 use cases and a total of over 100 clusters, and it just keep growing. We just cannot keep up the demand, actually. So what are the use cases for search? There are the traditional text search use case, and catalog search is very common those days because the data size are huge, and you want to build some metadata on top of the data and keep the raw data in another storage like Cassandra. So this is what catalog search is. And analytical search is about data exploration. We find our data scientists actually came to us and saying, Elasticsearch is great with real-time search. And so before I build this lengthy pipeline to Hadoop, can I look at my data and then I can figure out exactly how to build. So we feel this is a great use case for Elasticsearch as well. And there are many user-facing features as well, from internal tools all the way to actually Uber application user-facing features like Uber Eats. So what are the challenges in this area? So there is a performance tuning that is different from logging performance. Is actually because then we deal with data modeling, we are dealing with query performance, which is different. And the scalability, we find the scalability with Elastic is also like the highest cluster is like over 4,000 QPS per second. We find it's extremely hard to keep improving over that limit. So with that, is there anything else? What's other challenges? So we have Uber Eats as an example. So search is an essential user experience because this is how you find out which restaurant, what menu you want to, which dish you want to order. So we find out there's additional, besides the logging side of challenges, we have ranking algorithms. How do we tightly integrate with machine learning pipeline? Just because there are going to be so many features that are going to impact the ranking, it is impossible to actually manually get that into Elasticsearch. So that brings us to how do we solve this? For us, we have identified many things that's special in the search space that we actually are very excited to solve by building a Wang search engine on top of Lucene. And the main areas we want to solve, one is real-time search. Basically, we want to reduce the latency to real-time. And we want more efficient partial updates. So Elasticsearch, as you probably know, that when you update, it's actually a delete and reindex. So how when we have more frequent updates, how do we improve that? And then this is each scenario. How do we do machine-based ranking? How do we integrate the two systems seamlessly? And in the end, it's a high scalability and auto scale. So in the end, to recap what we talked about, what makes it challenging and interesting is the Uber scale. We have solved a lot of problems for logging, and we know how to work out scalability. But we find out there's another space that's completely open, that is how do we do search? Search scenario is essential in modern applications.